We're back, right? So series, parallel, okay? And in this video, we're going to look at how do you calculate total resistance, okay, for each of the type of connections. So let's go through the easy one first. So series, let's say this is R1, R2, and R3, okay? So if you were to find what is the total resistance, this is the formula. R total is equals to R1 plus R2 plus R3. And if you have more resistors, you just add them on. So what that means is that if we were to assign numerical values to this, okay, let me use a different color so you can see. Right, let's say you have 2 ohms here, 3 ohms, and 4 ohms. So total resistance will be equals to 2 plus 3 plus 4. How easy can it get, right? Equals to 9 ohms. Okay, so that is how you calculate total resistance, okay, or composite resistance of resistors connected in series. Okay, parallel right now. So again, let's say this is R1, R2, and R3. Okay. Okay, 1, so this is slightly more complicated, but you will get there. 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so it's much easier to illustrate this using numbers. So if we have 3, and let's say this is 2 ohms, 3 ohms, and let's give it 3 ohms as well. Okay, so the formula will give us 1 over R total is equals to 1 over 2 plus 1 over 3 plus 1 over 3. Okay, this part of it is math. So the common factor is 6. So this becomes 3 over 6 plus 2 over 6 plus 2 over 6. Okay? So 1 over R total is equals to 3, 2, 2 will be 7 over 6. Okay? Right? R total, you invert it across, will be 6 over 7. And I believe this is 0.6777, right? So 0.67 ohms, all right? Okay, so understand how you calculate combined resistance series, just add them up all together, all right? Parallel, okay, is, 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus so on and so forth, okay? R4 goes on, okay? All right, next video, we're gonna look at more examples. See you then.